Hello everyone and welcome to episode 10.2 of Zero to Hero Full Stack plus Y plus AI Engineer. In episode 10.1, we wrote a basic Docker file from scratch, but today we are going through real world Docker file builds that engineers actually use in production. We are talking multi-stage builds, layer caching, dev volumes, networking, health checks, and security. By the end of this video, you will know how to build like the pros do. Let's go. About me. I'm Siddhant Kumar, a full stack plus Y plus AI engineer. I have been building production systems since 2021, and here's the thing. Every pattern I teach is something I have actually implemented in real shipping systems. This course is not theory, it is battle tested infrastructure. Before we dive in, I want to ask you which pattern matters most to you right now. Is it image size, build speed, or security? Drop your answer in the comments. I read every single one. Alright, let's talk about the wall between it works and it ships. Here's a basic Docker file most beginners write. From Python is to latest copy dot dot run pip install cmd python app.py. Looks innocent, right? Wrong. This thing is a production disaster waiting to happen. Do you know 73% of container security issues come from images running as root? That's from the SysTick 2024 Container Security Report. 73%. And real talk, has your container ever failed in production? Be honest. If you said yes, you are not alone. If you said no, well, give it time. Okay, here's how I want you to think about this. Your Docker file is like a professional kitchen. A basic Docker file that's like a fast food joint. It works, but nobody's giving it a Michelin star. A real world Docker file that's a Michelin star safe kitchen. Every step optimized, every ingredient measured, presentation flawless. Here's our menu today. Multi-stage builds. Prep ingredients in separate kitchens, then assemble smaller, cleaner, faster final images. Layer caching. Prep your miss and place ahead of time. Only recook what changed. Development volumes. A live testing station. Adjust the recipe without restarting the whole kitchen line. Container networking, private corridors between keychains, services talk without exposing everything to the dining room. Health checks, a quality inspector at every station. Catch issues before they reach the customer. Non-root user security protocol, prevent privilege escalation and container escape attacks. The flow goes prep, catch, test, network, inspect, secure. Without these patterns, you are serving fast food with them. You are running a Michelin star kitchen, I believe. Pattern 1, multi-stage builds. Think of it like this. Separate the kitchen from the dining room. Before multi-stage, your image is a bloated mess. Best OS build tools like GCC and Make. Python dev headers, virtual environment, source code, compiled artifacts, app runtime, all crammed together. That's 1.2 gigabytes. Your container is basically wearing a winter coat in summer. After multi-stage, you strip it down to just what you need. Best OS virtual environment app runtime, boom, 180 megabytes. That's 83% smaller. Your container went from a sumo wrestler to a marathon runner. Here's how you do it. Stage 1 is the builder from Python 3.1 to Slim AS builders. You copy requirements, install dependencies. Stage 2 is the runtime. another slim image, and you just copy from builder, build artifacts, clean, fast, production ready. Pattern 2, layer caching. Catch your miss and place because order matters a lot. Here's the magic. When you build a Docker image, each instruction creates a layer. If a layer hasn't changed, Docker skips it. So, if you structure your Docker file smartly, you only rebuild what actually changed. The correct order: copy requirements.txt first, then run pip install, then copy dot dot. For actual code, why? Because your code changes all the time, but your requirements barely do. So pip install stage cached. Your wrong order, copy dot dot first. That invalidates catch every single time because your code changed. Then you run pip install again, full reinstall every single time. The result: native build 4 minutes 32 seconds, cached build 8 seconds. That's a 93% speed up. You just turned a tortoise into a cheetah. Pattern 3, non-root user never give keys to the kingdom. By default, Docker containers run as a root. User ID 0. That's the same user ID that owns your host kernel. It's like giving a stranger the master key to your house and saying, make yourself at home. The fix: create a non-root user app user. With user 1000, principle of least privilege: give the container only what it needs to run, nothing more. Why does this matter? Three scary words: privilege escalation, container escape, and host compromise. Running as root increases your container breakout risk by 8 times. That's from Aqua Security Research. 8 times. Would you bet your production on those odds? Pattern for health checks. Quality inspector at every station. Without a health check, your orchestrator is basically saying, is it dead? I don't know. I will wait. And it keeps routing traffic to a dead node. Your users are hitting a wall and you don't even know it. With a health check, your orchestrator says unhealthy. Replace in 3, 2, 1, and auto restarts the container before you just even notice something went wrong. Here's the code: health check dash dash interval 30-second dash dash timeout 10-second and retries 3. Then a curl to your health endpoint. Every 30-second, 10-second timeout, 3 retries before marking unhealthy. Self-healing infrastructure starts here. Pattern 5, development volumes. The live testing station. Instant code sync. Picture this: you are coding in your editor, you save a file, and bam, your container detects the change, reloads, and restarts in zero point 0.3 seconds. No rebuild, no waiting, just pure developer happiness. Without voice, heavy code change means full read. 3 minutes, 12 seconds of staring at your screen, questioning your life choices. With volumes, zero point 0.3 seconds. That's not a typo. 0.3 seconds. Pattern 6, custom networks. Private corridors between keychains. You have your web container, your API container, and your database container. They need to talk to each other, but don't want some random attacker from the internet chiming in and saying hello to your database. Custom networks solve this. You create an isolated bridge network, let's call it app network, and pull all your services inside it. They can discover each other by name. Your Postgres is to //db5432 built in DNS. No exposed ports between services. Attacker on the outside blocked. Queues for you. Can default bridge services discover each other by name? Drop your answer in the comments. I want to see who was paying attention. Alright, Final challenge. Spot the mistakes. I have got a Docker file here with 5 production failures hiding in plain sight. You have got 30 seconds. Go. Here's the code from Python latest. No version pin, copy dot dot before pip install bad cache order, no user instructions, running as root, no health check. Your orchestrator is flying blind and expose 22. SSH port exposed. Why? Just why? These are not just stylistic preferences. These are production failures waiting to happen. How many did you catch? Be honest in the comments. First, let's create a dedicated workspace for this Dockerfile series. In your terminal, navigate to your project root. For me, it is 0 to hero. Create a new directory for advanced Dockerfile patterns by typing command mkdir space -p space docker file series. Docker file series is a directory which I created in previous episode, and in this directory I will create a new directory which is 10.2 real world builds. I am creating this. You can create as for your wish. Now I will navigate to this directory by typing command cd and path address of 10.2 real world bits. Create our files by typing command touch space app.py space requirements.txt space dockerfile space docker-compose.yml. Open this file in VS Code editor by typing code and then all the files name app.py, requirements.txt, Dockerfile, docker-compose.yml. We will start with a minimal Flask app for testing. In app.py file, I copy code with simple health endpoint and paste here. You can pause this video and write this code. In requirements.txt file, add these pip applications first Flask version 2.3.3, then Gunicorn version 21.2.0. This gives us lightweight app with Gunicorn for production ready serving, and also add Redis version 5.0.1 which is for database testing. Now, the heart of this episode, a production ready multi-stage Docker file. Now we start from zero. Type the first line, start with hash, stage 1, builder, install dependencies. This is a comment. It helps humans understand the file. Press enter. Now define the first stage by typing in capital letter from space in a small letter Python is to 3.12 dash slim in capital letter after a space type as, then a space in a small letter type builder. From tells Docker which base image to use. Python 3.12 slim is a lightweight Python image. AS Builder names this stage so we can reference it later. Next, set the working directory for this stage. Write in capital letter work dir space slash in a small letter build. This creates a clean folder inside the container for our build work. Press enter twice. Now we copy only the requirements file first. This is a key optimization. Type comment copy only requirements first for layer caching. Press enter. Type in capital copy space in a small letter requirements.txt space dot. Why copy only requirements first? Because Docker caches each layer. If requirements.txt does not change, Docker reuses the cached pip install layer, saving build time. Press enter. Now install dependencies into a virtual environment. type comment install dependencies to a virtual environment, press enter, type in capital run space in a small letter python space dash m space vnv space slash opt slash vnv, press enter, in capital type env space path equal to underquote slash opt slash vnv slash bin is to dollar path, press enter, in capital type run pip space install space backslash, press enter, dash dash no dash catch dash dir space backslash, press enter, dash dash default dash timeout equal to 100 space backslash, press enter, dash dash retries space 5 space backslash, press enter, dash r space requirements dot txt, press enter. Let me explain the flags. Dash dash no catch dir keeps the image smaller by not storing pip cache. Dash dash default dash timeout equal to 100 and dash dash retries space 5 make installs more reliable on slow networks. Dash r space requirements.txt tells pip to install from our file. This stage now has all our dependencies in a virtual environment at /opt/vnv. Now we start the second stage, the runtime stage that will be our final image. Type comment runtime minimal image with only what we need. Press enter, in capital type from space python is to 3.12 dash slim space in capital as space runtime. This starts a fresh, clean stage based on the same slim Python image. Press enter. Now copy the virtual environment from the builder stage. Type comment copy the virtual environment from the builder stage. Press enter. Type in capital copy space dash dash from equal to builder space slash opt slash vnv space slash opt slash vnv, press enter, in capital type env space path equal to underquote slash opt slash vnv slash bin is to dollar in capital path, press enter. The dash dash from equal to builder flag copies files from the named builder stage. We are copying only the virtual environment, not the build tools or source code. Setting the path ensures our app uses the virtual environments, Python and packages. Now set the working directory for the runtime stage. Type in capital work dir space slash app. This is where our application code will live. Press enter. Now copy only the application code. Type in comment not build tools. Press enter. Type in capital copy space app.py space dot. Press enter. We are copying only app.py, not the entire project. To keep the image minimal in a real project, you use a Docker ignore file to exclude unnecessary files. Security is critical. Let's add a non-root user. Type comment create non-root user for security. Press enter. Type in capital run space user add space dash dash create dash home space dash dash cell space slash bin slash bash space app user space and space backslash. Press enter. Type chown space dash r space app user is to app user space slash app. Press enter. Type in capital user space app user. Press enter. This creates a new user app user with a home directory and bash shell. Then changes ownership of app to that user. Finally, app user tells Docker to run the container as this non-root user. Why does this matter? If an attacker exploits a vulnerability in your app, they are limited to the permissions of app user, not root. This is a critical defense in theft practice. Now, expose the port our app will use. Type in capital expose space 8000. This documents the container listen on port 8000. It does not publish the port, but it helps orchestration tools understand the app. Press enter, type a comment, health check for orchestration system. Press enter, type in capital letter, health check, then space dash dash in a small letter, interval equal to 30 seconds, space dash dash timeout equal to 10 second, space dash dash start dash period equal to 5 second, space dash dash retries equal to 3 backslash, press enter, cmd in capital space python space dash c space undercode type import url lib dot request semicolon url lib dot request dot url open under parenthesis type in single quote http is to slash slash localhost is to 8000 slash health, close the single quote, parenthesis closed, underquote closed, use or symbol after a space and again a space and exit space 1. Press enter. Let me break down the flags. Interval 30 seconds. Check every 30 seconds. Timeout 10 seconds. Wait up to 10 seconds for a response. Start period 5 seconds. Give the app 5 seconds to start before checking. Retries 3. Mark unhealthy after 3 consecutive failures. The command uses Python to make a simple HTTP to help. If it fails, exit 1 tells Docker the health check failed. This enables Docker, Kubernetes, or other orchestrators to automatically restart unhealthy containers. Finally, define how the app starts. Type in comment, use Unicorn for production serving. Press enter. Now type in capital CMD space start square bracket type underquote Unicorn in a small letter comma space underquote dash dash bind comma space underquote 0.0.0.0 is to 8000 comma space underquote dash dash workers comma space underquote 2 comma space underquote app is to app close square bracket. Why Unicorn? Flask's built-in server is for development only. It's not for designed for production traffic, concurrency, or signal handling. Unicorn is a production-grade WSGI server that handles multiple workers for concurrency, properly manages signals for graceful shutdowns, is battle-tested in real deployments. The bind 0.0.0.0 is to 8000 makes it listen on all interfaces, workers to starts to worker processes, app is to app tells Unicorn to import the app object from app.py. Now in docker-compose.yml file, I'm going to copy and paste the configuration code. You can pause this video and type it manually. Now let's build and test. In your terminal, run command docker dash compose space build space dash dash no dash sketch. Watch the output. You will see two stages buildings. First one, builder, installing dependencies. This layer catching on subsequent building. Runtime, creating the minimal runtime image after build completes. Check the image size by typing command docker space image space or space script space copy and paste the image name from the build's output. You should see runtime image for a single stage build. Now start the services by typing command docker dash compose space up space dash t. Wait a few seconds for health check to pass. Test the health endpoint by typing command curl space http is to slash slash localhost is to 8000 slash health. See the output status healthy. This confirms multi-stage build succeed. Health check is working. App is serving request on port 8000. Now let's test the development workflow. Edit app.py and add a new route. You can pause this video and type the input I am adding in here and save the file. Because we mounted app.py as a volume, the change is reflected instantly. No rebuild needed. Test the new endpoint by typing command curl http is to slash slash localhost is to 8000 slash test. You see the result. Message test endpoint is working. Now let's retest. Let's update the message again. Live reload works. Rerun the test command and see the message live reload works. This is the power of development volume, rapid iteration without rebuilding images. Finally, let's test container networking. Add a second service to docker compose.yml, a simple Redis sketch. You can pause this video and type the part I have written. Let's restart our services. First, we will stop the container by typing command docker-compose space down. Oh, we have an error here. It is a spacing error. Remember, the docker-compose.yml file is very strict about spaces. Let me fix the spaces in the editor quickly. Okay, done. Now stop the containers again by typing command docker-compose space down and restart it by typing command docker-compose space up space dash t. Everything is running now, and let's test if the app can find the catch by its name. We will write this command. Just pause the video and type this command I have written. Look, it shows an IP address. This means the app can find the catch inside our network. This is how microservices talk safely. They use names, so they do not open public ports. Let's recap what we learned to write today. Created a dedicated workspace for advanced Dockerfile patterns. Wrote a minimal Flask app with health endpoint for testing. Built a multi-stage Dockerfile that shrinks images by 60 to 80%. Implemented layer caching strategy for faster CI/CD builds. Added non-root user for container security. Configured health check for orchestration and self-healing. Set up development volumes for live code reloading. Isolated services with custom Docker networks. Tested all patterns with Docker Compose build and up. Now have the foundation for writing production-ready Docker files, not just for this course, but for any project you build. If this video helped you, please subscribe to Hero Stack Academy and hit the notification bell. Episode 10.3 will drop soon. Support this course. This course is 100% free and open source. If it helps you, consider becoming a GitHub sponsor. Your support funds server cost, domain renewals, and more free content. Join our Discord community. Share your setup, ask questions, and connect with other learners. Start the GitHub repository. It helps others discover this course. I am Siddhant Kumar, full stack and AI engineer working professionally since 2021. This course is my passion project to help developers like you master enterprise-grade skills through hands-on learning. You can connect with me on LinkedIn, GitHub, or by email. All links are in the description. Drop a comment below. Real world ready. If your file now includes multi-skills, health checks, and proper networking. Thank you for watching. I will see you in episode 10.3. Happy coding.